You ready? Okay, today we are going to start another method of factoring. This method is called grouping. We use this method when we see 4 or more terms. What method did we use yesterday? But factoring by what? What were we looking for? The greatest common factor. So just because yesterday was GCF does not mean that the GCF goes away. With your eyes, there are 11 polynomials on this page. See if you can scan and find a problem that has a GCF that you could factor by. Austin.
7.
Number 7 has a GCF, so I want you to give it a little star. Okay, what is that GCF? 2. Okay, so I want you to keep that in mind. Just because today we're learning another method does not mean yesterday's method is not used. In fact, we are always going to be looking for a GCF first. But it is important that you look for those when possible. So when we factor by grouping, we usually will see 4 terms and we ask ourselves, hey, did these 4 terms have a common factor? Well, if I look at this example, 6ax plus 3ay, hey, it looks promising. Both of these have an a, and they're both divisible by 3. Uh-oh, 2bx. This doesn't have an a, and it's not factorable by 3. So when we run into that issue of there is no GCF, but there are 4 terms, we group. So instead of trying to look for the GCF in 4 terms, we say, okay, I'm gonna group 2 terms by 2 terms. And I'm gonna see if I can find the GCF out of these groups. What is the GCF out of my first group? 3a. 3a is my common factor out of my first group. What is left in the parentheses? 2x plus y. Because that is 3a times 2x gets us 6ax, and 3a times y gets us 3ay. What is my common factor out of my second group? Is it a positive b or a negative b? It's a positive b, so I'm going to write plus b. If I factor out a b, what is left in my parentheses? 2x plus y. Is it a coincidence that these binomials match? No, it is not a coincidence, and it's super important. When you are grouping, you need to get a match, because then that binomial becomes the common factor. 2x plus y is our common factor in both groups, so it's now the GCF. So I say, okay, I'm going to factor out 2x plus y, and what's left? 3a plus b. Let's check our work. So 2x plus y times 3a plus b is the same thing as 3a plus b times 2x plus y, right? So if I check using the FOIL method, because this could be multiplied, I say, what's 3a times 2x? 6ax. Okay, outside, 3a times y. Inside, 2bx. Last, plus by. Do you see how that matches what we started with? Okay, so that's why grouping works. If I'm looking at number 1, notice here first, when I grouped these, I did not include that plus sign. It is important for me to know that you understand that you're not multiplying these groups, that you're factoring them. So this plus sign remains in between them to say, hey, yes, I'm grouping them, but I'm not changing the value. On number 1, it's not a plus sign for my middle sign. So when you do that, you need to understand that that negative belongs to this x, but we are still adding these because we are not changing their value. So then I ask, what is my common factor out of my first group? X. Okay. So what is left in my parentheses? X minus 2. Now here's the problem. I know that my binomials that I leave in parentheses need to match because I need a GCF. But right now, what would I factor out to make that happen? Because this says x minus 2, but this says negative x plus 2. And we know that those two things are not the same. So what can I factor out to make matching binomials? A negative 1. So if I factor out a negative 1, everything changes signs, and now I have matching binomials. So my GCF is now x minus 2, and is being multiplied to x minus 1. So 3 steps. Group, GCF from each group, write your binomial pairs. So let's move down to this one. First step is to group. Now this has a plus sign, so I don't have to include it because it is implied that the 3 is positive. GCF from each group. What is my GCF from this first group? And if 4m is my GCF, what is in parentheses? M plus p. What is my GCF from the second group? 3p. And if 3p is my GCF, what is in my parentheses? M plus p. Now, what I have for my matching binomial, I tend to write first, but that's just my preference. I could also write 4m plus 3p here times m plus p, and that is also correct. Okay, so order of the binomials does not matter. Yeah, number 2. I have a negative here. That negative belongs to the 4, but these are still being added. We're not changing the value of this polynomial. What do I factor out of the first group? 3x. And what's left behind? 3 times what is 12? Okay, the x is taken care of, but the a is not. Plus, the 3x times what gets me 3xz? Hey, what should I factor out of this second group so that I have a matching binomial? Negative y. So then I have 4a plus z. I had some people in second period accidentally leave this step as their final answer, but are we finished? No. So you need to identify your greatest common factor and then write your second binomial pair. Okay, last one together. GCF of the first group, 3a. And if I factor out a 3a, what's left on the inside? 4a plus 1. Remember, if I take out the entire monomial, then I have to leave behind a 1. If I factor out 3a, then it's a 1 here. What do I factor out of the second group? Negative 2, and I leave behind 4a plus 1. So I have 4a plus 1 times 3a minus 2. Okay, so we're going to go over these problems a little bit differently after you do them. I'm going to give you 5 minutes. If you finish these first 6, go on to the back to get some practice. But these are the 6 problems that we'll go over. Remember, we starred number 7. Why did we star number 7? It has a GCF, so start on number 7 by factoring out the GCF. Now, after we do this, I'm going to take 6 people's problems and we're going to go over them on your work. So please make sure that I can follow your work because I could choose any 6 of you to go over any of these problems. Okay, on this one. So, minor changes I would make to your work, not necessarily your answer because your answer looks wonderful. But when you're including that, make sure you include your parentheses with the negative and that this is being added because the negative belongs to the 2. But you did exactly the right thing by factoring out a -2 and we have a correct answer here. Any questions on number 5? Just a few changes I would make on your work because your answer is almost correct. So here you factored out an A, great. Here you factored out a 3, but let's make sure we know that it's a positive 3. And then because you are finding the factors and you are going to be multiplying, like they're multiplied to get this product, there is no plus sign there. You're multiplying these. Okay? Thank you, Mia. And then, all right. So this one was the one where we had a GCF. So we take out our GCF, we get 2b squared minus 6b minus b plus 3. And the 2's out here the whole time. So on this one, you factored out a 2b from your first group, which is fine, b minus 3. But when you factor out this negative, it's not just a negative, it is a -1. Okay? And so this 2 is right here, so I'm gonna, your 2 is still here. 2b minus 1, b minus 3. So, Brooklyn, this is great. You factored out an A from your first group and a 1, but let's make sure we know it's a positive 1. Then close your parentheses. And then A plus 1 times X plus Y. Very good. Any question on number 8? So when you have something with a group that there's nothing you can factor out, what do you factor out? 1. Good showing work here. On this one, we would take out a -4. On this one, when you took out the A, you're leaving an A, so A times A makes A squared. Yeah. It would just be a -4 because there is no A on that one. So this one, we don't want to change the order because this says 4A minus 5B and we need them to match. So this would be -4 times 4A minus 5B. Okay. So 4A minus 5B, 3A plus 4. Questions on number 9? Okay, and on number 10, factor out a P from your first group, leave P minus 2Q. Factor out an R from your second group, leave P minus 2Q. So my 2 binomials are P plus R times P minus 2Q. Any questions on that one?